Good day to you, and thank you for joining Geometry Notes Made Simpler. Today we're going to look at complementary and supplementary angles. I always say when you're doing any math, whether it's algebra, geometry, trigonometry, or calculus, always keep you a note box on that page to remind you of certain rules to go along with the type of equations you are studying. And you always set up your notes in a way where you're in a step-by-step formation when you're doing your equations. That helps you to remember to stay in order with the proper way to write down your equations. Some teachers do dock you for not writing your equations properly, even though you get the correct answer. Because it's very important when it comes to doing any type of math. So with that being said, let's look at first the rules that go with complementary and supplementary angles. We know the word adjacent. Adjacent means attached. When something is adjacent to something else, it is attached to it. Angles are said to be adjacent to each other when they are angles like these two within one larger angle. These two angles are adjacent to each other because they both sit within one larger angle. Non-adjacent is two separate angles. Two separate angles, they are not attached. They are not adjacent. These two are attached to each other, they are adjacent. These two are two separate angles, they are not attached, so they are non-adjacent. Complementary angles are angles that adds up to 90 degrees. What's the name of a 90-degree angle? It is titled the right angle. How do we recognize the right angle? It is the only 90-degree angles with the square in the corner. Only 90-degree angles with the square in the corner. And you must draw that square in the corner to represent your 90-degree angle. That is more important than writing the number 90 in that corner right there. You don't have to write that number 90 all the time, but you do all the time must draw that square for the corner of a 90-degree angle. Very important. Supplementary angles. And how do you remember complementary angles is 90 degrees? Because of the square in the corner. Complementary begin with a C. Corner begin with a C. That's your memory. Yep. Complementary angles is the angles that go with the corner angle. What is the corner angle? The 90-degree angle. Complementary angles are angles that add up to 90 degrees. Now we have supplementary angles. Supplementary begin with an S. Supplementary angle are angles that adds up to 180 degrees. The name for the 180-degree angle is the straight angle. Supplementary angles begin with an S, straight angle. You have to remember, why is it called straight angle? Because it's a straight line. 180 degrees is the angles that represent the straight line. Whenever you are writing any angles, you write the number with the arc over it. All angles must be written with the number and the arc loop over it. All angles except only one angle, and that is the 90-degree angle. That's the only angle that you write with the square in the corner. All other angles, even a 180-degree angle, must be written with the arc circle over it. Okay? Now, let's look at our complementary angles. That is up to 90 degrees. We know it by the corner square. No matter how you turn this or flip this, if you ever see that square in the corner, it means that angle is 90 degrees. Sometimes you will get equations that has no number in the corner, just that little square. You cannot say I got it wrong because I know what number was in that square. You are expected to always know. That means 90 degrees. Okay? Now, we are to look at the word adjacent again. Like I said, no matter how you divide this angle up, this is a 90-degree angle. How do we know? 25 plus 65 equals 90. That's a 90-degree angle. These two angles are considered complementary angles. If this angle is 20 degrees and this angle is 7 degrees, these two angles do add up to 90 degrees. How do you know? It's a complementary angle. Two angles is complementary when they add up to 90 degrees. So we can put our equations there. We can put in any one. We can put in any number we so choose to. And we can, if we want, do 65 and 25 equals 90, or we can do 20 and 7. One thing we do know, these two are adjacent to each other because they're both within that same angle. These are all non-adjacent angles. One area for one angle. They are not adjacent. They are non-adjacent. They are not attached. Now, which two will add up to 90 degrees? We have a 45 and 45. That adds up to 90. And we have a 25 and 65. Those add up to 90. So, these two are non-adjacent angles, but they are complementary angles. Those two are complementary angles, and those two are complementary angles, but non-adjacent. Now, let's look at this one here. This one here is a 95-degree angle, and this here is a 35-degree angle. Do they add up to 90 degrees? Do they add up to 90 degrees? 95 and 35 is 140. No, they do not add up to 90 degrees, so they are not complementary angles, no. Are they adjacent? Yes. They are both attached within the same area, so they are adjacent angles, but they are not complementary. And this is the reason why you are told to always have that square in the corner when representing 90 degrees. Always. Reason why is some angles can look like 90 degrees, but if you don't see that square in the corner, you do not assume it's a 90-degree angle. Like this here. There is no square in the corner. You see a 95 right here. You don't see a square, but if there was no number here and just the arc and they ask you to find that number, you do not look at this and say it looks straight up and down, it looks straight across, that's 90. It would be wrong. If you do not see that square, it is not a 90-degree angle. And as you could see when it was measured, it was 95 degrees. So even though it looked like 90, it was 95. Okay? So that's just rules to remember, because you will get equations like this, and sometimes you'll get equations without your little hint right there. So this makes it easy. We can set up all these equations to equal 90 degrees because all of these equations have that little square in the corner. All of them. That means this whole area is 90 degrees, and no matter what these two are, they're going to equal 90 degrees. So we would set up our equation to equal 90 degrees for all of these, and then we're going to do our equation as an algebraic form. What we know about the algebraic form of equations, we have a variable for the missing area, and then we do our simple notes of how we do our simple notes here to remind us, like I said, a note box, to remind us of how to complete it in algebraic form. Very simple way that we get used to setting up our equations in. Fill in our gaps first. We have an A here. We have a 34 here. And we want to separate our coefficients from our variables. Separate the coefficient from the variable by moving the coefficient. Coefficient means only numbers, no letters, only numbers. The letters are called variables, okay? And the numbers are called coefficients. So we're going to separate coefficients from variables by taking the opposite of that coefficient. If it's a positive 34, the opposite would be a negative 34. If you do it on this side, you must do it on the other side of the equal sign as well. Negative 34. There you go. Now, A comes down. Positive 34 and negative 34 cancels out to 0. Bring your equal sign down. 90 minus 34 is, that's our 8. That's a 10. 10 minus 4 is 6. 8 minus 3 is 5. So, our A equals 56. That's this area here, 56. How do we write our 56? We write the number with the arc over it. That shows our area 56. Let's get us an eraser to erase this little mark there. There you go. Now, let's do the same thing for here. Always follow the simple instructions. We're going to plug in our gas first. We have a 39. We have an A here. Okay, now we are to do what? Separate our coefficients from the variables first by taking the opposite of the coefficient. If we do it on that side of the equation, we must do it on this side of the equation as well. And we would take the opposite. 39 minus 39 is 0. We will bring down our A, bring down the equal sign. 90 minus 39 is, that leaves our 8. That put that 1 over there. 10 minus 9 is 1. 8 minus 3 is 5. 51. And we would do the same here as well. We will plug in our gaps. We have 47. We have A over here. We're going to separate our coefficients from our variables. We do it on this side like we do it on that side as well. That cancels out. That's a 0. We just bring down the A equals, and 90 minus 47 is, there's our 3. That is 43. We would do the same for any equation we have that we're finding the variable on. This is the way you are expected to set up your equation so you can have what your variable equals. Solve for your variable. Okay. Now here is your directions for. First, separate your coefficients from your variables. After you do that, sometimes you might have a coefficient stuck on your variable, attached to your variable right there. When you do that, when you have that, you then have to divide those off of your variable. When you get your variable by yourself, then you can solve for your variable, which is what you did. So we're also going to look at supplementary equations. Remember also that you must practice many equations when you are doing your math, whether it's algebra, geometry, calculus, or trig. Calculus or trig. You must always practice your equations over and over. Once you learn the order to do the directions in, you do not stop saying, now I know how to do the equation. You have to practice your equations over and over. Always copy these, get even more offline. Find you a lot of different equations because they would always be set up in different ways. And you have to be used to doing them in different ways in a very quick fashion. The only way to become very quick at doing these is remembering these directions and doing your equations quickly is practice, practice, practice. It's the reason why you are given so many equations on your math exams. You are not just expected to know how to do them, but you're expected to know how to do them in a fast pace, okay? So let's also look at our supplementary angles. Our supplementary angles are the same way. Now, keep our notes at the top because this is our we're going to learn the supplementary page, but we keep our notes at the top. And we remember adjacent means attached, complementary, C for complementary, C for corner is for the corner. It's the angle with the square in the corner, and those add up to 90 whether they are attached or even if they're not attached. If they add up to 90, they are complementary. And supplementary is angles that add up to 180 degrees. 180 degrees is your straight line. That's why the name of that angle is called straight angle. And all angles that are not this one here will have the arc over it, including the 180-degree straight line angle. So when we are doing supplementary angles, they are angles that adds up to 180 degrees, no matter how you divide it. If the angles add up to 180 degrees, they are supplementary angles. And the name for those angles are straight line angles. Okay, and that's whether the straight line is straight up and down for vertical or whether it's horizontal or in any direction. If it's a straight line, that angle adds up to 180 degrees. Okay, now looking at these two, they are adjacent angles. Together, they do add up to 180. This is a 100-degree angle, and that is a 80-degree angle. Together, they add up to 180, so they are supplementary angles. This is a 55-degree angle, and this is a 125-degree angle. Together, they add up to 180, so they are both supplementary angles. Okay, now this angle here, these two angles here, this is a 120-degree angle here, and this is a 75-degree angle there. Do they add up to 180? No. They add up to 120, and 75 is 195. So they are not a supplementary angle. Are they an adjacent angle? Yes, they're attached to each other. They're both within the same angle. So yes, they are adjacent angles, but no, they are not attached. They are not supplementary. They are attached, yes, but they are not supplementary because they do not add up to 180. Now these here, are they adjacent? No, these are non-adjacent angles. They are angles by themselves. Each one has their own number. They are not adjacent angles. But which ones add up to 180? This is a 70-degree angle. That's a 110-degree angle. That adds up to 180. So these two angles are supplementary angles. This is a 35-degree angle, and this is 100 and the other one is a 145-degree angle right here. Do they add up to 180? Yes. So these two are supplementary angles as well. Now, you follow the same pattern for doing supplementary angles. You follow the same pattern for solving. Fill in your gaps. This angle here is 145 degrees. And the missing angle that we're looking for, we call it angle A. That's our variable. And we want it to add up to 180. So how do we do that? We separate our coefficients from our variables as usual by taking the opposite. If you do it on this side of the equation, you must do it on this side of the equal sign as well. There you go. Now, then we subtract off. 145 minus 145, that's a 0. So bring down our A. Bring down the equal sign. 180 minus 145 is, this becomes a 7. That 1 goes to that 0. That becomes 10. 10 minus 5 is 5. 7 minus 4 is 3. And 1 minus 1 is 0. So A equals 35. This angle is a 35-degree angle with the arc over it. That's how that goes. All right, let's do another one here. We have our A, that's what we're missing, this angle here, and we have 45-degree angle there. Okay, we are to first what? Separate our coefficients from our variable. There you go. By taking this opposite, the opposite of positive 45 is a negative 45. We must do the same over here, negative 45. Do that to the other side of the equation and bring down our A. 45 minus 45 is 0. That goes away. Bring down the equal sign. 180 minus 45 is, cross out that 8. That becomes 7. Move that 0, that 1 over to the 0. That's a 10. 10 minus 5, that's 5. There you go. 7 minus 4, that's 3. And we bring the 1 down. There you go. So, A equals 135. All right. So that's this angle here, 135. Always put the arc over it. There you go. That is how you solve these equations. You will practice doing more and more of these equations so you can become faster at solving them, okay? You want to become faster at solving your equations. That is how you get your 90% or better on your exams, by finishing all your equations in the recommended time given. You are given a lot of equations because you expect to practice until you're able to solve them faster. Thank you for visiting Geometry Notes Made Simpler, and I hope to visit you in the next video, and may you have a very good day.